Greetings from Institute of Aeronautical Engineering and welcome to IARE ELRV course on electromagnetic waves and transmission lines. This is Dr. Y. Pandu Rangaiah, Associate Professor in the Department of Electronics and Communication Engineering, Institute of Aeronautical Engineering. And in today's session, we'll discuss about problems on Coulomb's law. More on that, we learned it is on Coulomb's law in the last session, and where we'll do that to solve some of the problems by using the Coulomb's law. So after completion of this session, the learners will be able to compute the electric field intensity. Due to that, the discrete charge distributions of it may be a 1-point charge, 2-point charge, or n number of the point charges, and how to determine the force or the electric field intensity at any point. We'll move on to that. The first problem. The given problem is the point charges 1 millicoulombs and minus 2 millicoulombs are located at 3, 2, minus 1 and minus 1, minus 1, 4 respectively. Calculate the electric force on a 10 nanocoulomb charge located at 0, 3, 1 and also the electric field intensity at that point. So here given the 2 point charges of 1 millicoulombs and minus 2 millicoulombs. 1 millicoulomb 1 into 10 power minus 3 coulombs and minus 2 millicoulombs minus 2 into 10 power minus 3 coulombs. They are located at 3, 2, minus 1 and minus 1, minus 1, 4 respectively. Calculate the force on a 10 nanocoulomb charge. So it is 10 nanocoulombs. Nano means 10 power of minus 9 coulombs, which is located at 0, 3, 1. And later calculate the electric field intensity also at this the point. Okay. First we'll calculate the force and later we'll go for electric field intensity. So here there are the 2 point charges. They are located here. And the third point charge is located at 0, 3, 1 of 10 nanocoulombs and is asking us to calculate what is the force on 10 nanocoulomb charge due to this 1 millicoulomb and due to this minus 2 millicoulombs of the charges. So that the total force on 10 nanocoulomb charge is due to, what is the force due to this the charge 1? I am considering it is a charge 1 millicoulomb and also that the charge 2 of minus 2 millicoulombs. So the force on 10 nanocoulomb charge due to that the 1 millicoulombs I will consider is on the F1. The force on 10 nanocoulomb charge due to that the minus 2 millicoulombs of the charge I can consider is an F2. Therefore, the total force is nothing but I can write is an summation of these two forces. F is equal to F1 plus F2. So, to calculate the force by using the Coulomb's law, we know that F is equal to Q1 Q2 divided by 4 pi epsilon naught R cubed into R bar. So, here Q1 Q2. So, here it is an 10 minus 3 1 millicoulomb into 10 power minus 9 divided by 4 pi epsilon naught. Let us assume that they are placed in a free space. So they are not given anything and we will assume that they are placed at free space into where we have to calculate at 0, 3, 1 minus due to which of this 1 millicoulomb of charge located at 3, 2, minus 1 divided by magnitude of 0, 3, 1 minus 3, 2, minus 1 whole cubed plus this is an F1. F2 is nothing but minus 2 millicoulombs minus 2 into 10 power minus 3 divided by 4 pi epsilon naught into again 10 into 10 power minus 9 into here at where we have to calculate 0, 3, 1 minus due to which minus 1, minus 1, 4 divided by 0, 3, 1 minus 1, minus 1, 4 magnitude of whole cube. Right. And this will start to calculate the force is equal to, in both the cases, 10 into 10 power minus 9. 10 into 10 power minus 9 is the common. And again 10 power minus 3 is also common. Right. And again here, this is an 1 millicoulomb, 10 millicoulombs. Okay, this is the common up to here. And I will take the 4 pi epsilon naught is also common. So here in the first term, 0, 3, 1 minus 3, 2, 1 minus 1 means 0 minus 3. It is an minus 3 Ix. Yes, 3 minus 2 means it is an plus Iy. 1 minus of minus 1 plus 2 Iz divided by 0 minus 3 means square root of 3 square means 9 plus 1 square 1, 2 square 4 whole cube plus, here it is, if I take all these things are common, minus 2 is there here into 0 minus of minus 1, 1 means it is an Ix, 3 minus of minus 1 means plus 4 Iy, 1 minus 4 means it is an minus 3 Iz divided by square root of, this is an 1 plus 4 square 16 plus 3 square 9 whole power of 3. Then if I simplify this expression, and we may get what is an the force expression, right? So this is an how to calculate the force. Then is asking that at the same point to calculate what is an electric field intensity. Electric field intensity E is defined as an the force per charge, that is the force per charge, which is given by E equal to force whatever the expression which we got divided by the charge. Charge is nothing but 10 power minus 9, 10 into 10 power minus 9 coulombs. So what will get? 10 power minus 3 divided by 4 pi epsilon naught into the remaining whatever it is there. So where we may get it is an, so minus 3 Ix plus Iy plus 2 Iz divided by square root of, it is 9 plus 1 10, 10 plus 4 14. So under root of 14 whole cubed minus 2 into the remaining is Ix plus 4 Iy minus 3 Iz divided by square root of 1 plus 4 16 plus 9 25 26 whole power of 3, this one. So this is the electric field intensity. If you calculate this, and we may get this answer. E equal to minus 650.7 Ix minus 381.7 Iy plus 750.6 Iz kilovolt per meter. So if you solve this expression, and you need to get this answer. So this is how we can calculate the force or the electric field intensity. Here only one point is the concentration point is, while calculating it is on the r bar vector, where we have to calculate. Suppose in this the case, we want to calculate either force or the electric field intensity at a point 0, 3, 1. So those point position vectors minus due to which we have to calculate. Suppose if it is a charge is located at 3, 2, minus 1, that is an F1 case. Therefore it will be becomes minus 3 Ix, 3 minus 2 it is an plus Iy, 1 plus 1 it is an the 2 Iz like this. Whereas in the second case, again we have to calculate it again 0, 3, 1 only, but due to which we have to calculate the charge is located at minus 1, 4. Therefore, where we have to calculate that point position vector coordinates minus due to which we have to calculate that point position vector coordinates. So this is only that the concentration point. Where the electric field, another concentration point is the electric field intensity is defined as the force per unit charge. That's all. This is how we can calculate a problem or solve a problem on this electric field intensity calculations. We'll do that the same kind of a problem one more. Let us look at this problem. where the 4 identical 3 nanocoulomb charges are located at P1, P2, P3, P4 of having the coordinates respectively, and find the electric field intensity at a point P1, 1, 1. See that it is an very simple. There are given it is an 4-point charges of each are 3 nanocoulombs. All are identical, but they are located at different places of 110, minus 1, 1, 0, minus 1, minus 1, 0, 1, minus 1, 0. Let us calculate the electric field intensity at a particular point 1, 1, 1. Now we will do that this problem. Electric field intensity is given by, at any point is given by the summation of superposition of the electric field intensities due to point P1, due to P2, due to P3, due to P4 of a charge of 3 nanocoulombs located at those points respectively. Therefore, first I will do that E equal to 3 nanocoulombs. All the charges are identical. So that 3 into 10 power minus 9 coulombs. That I will take it is an common. 4 pi epsilon naught is also common. That I will write it is an outside. Now, due to that the charge at 1, 1, 0, what is the electric field intensity at 1, 1, 1? So, where we are calculating, that is important. So, right? Where we are calculating at 1, 1, 1. So, due to which that is 1, 1, 1 minus due to which at 1, 1, 0 divided by, again it is the magnitude of 1, 1, 1 minus 1, 1, 0 whole cube plus due to the second charge located at minus 1, 1, 0. Again it is where we are interested to calculate at 1, 1 minus 1, 1, 0 divided by magnitude of 1, 1, minus 1, 1, 0 whole cube plus due to the third charge again at 1, 1, minus 1, 0 divided by magnitude of 1, 1, minus 1, 1, 0 whole cube plus again the fourth charge at 1, 1, minus 1, minus 1, 0 divided by magnitude of 1, 1, minus 1, minus 1, 0 whole cube. I'm sorry, here it is the minus 1, minus 1, 0 whole cube. Summation of all these things. So therefore, I will start to calculate here E equal to 3 into 10 power minus 9 divided by 4 pi into here. Again for easy simplifications, epsilon naught value we can write it as an. There are the two ways. One it is the epsilon naught, we can write it as an 8.854 into 10 power minus 12 farad per meter. Or for easier calculations, it is also can be written 1 divided by 36 pi into 10 power minus 9 farad per meter. So here if I use 1 divided by 36 pi into 10 power minus 9, then it is easily gets cancelled this 10 power minus 9, 10 power minus 9, 4 pi it is a 9 times it is cancels. Therefore, E equal to 3 into 9 will get easily. So, I am substituting the epsilon as an 1 divided by 36 pi into 10 power minus 9 farad per meter for easy calculations. Here come here 1, 1, minus 1, 1, 0. So 1 minus 1, 0, 1 minus 1, 0, 1 minus 0 is Iz will get divided by square root of 1 whole cube means it is on the 1 only I will get plus. So the second one 1 minus of minus 1 means it is on the 2ix, 1 minus 1, 0, 1 minus 0 plus Iz and divided by square root of 4 plus 1 means I will get is on the 5 whole power 3 by 2. And the third one 1, 1, minus 1, minus 1, 0. 1 minus of minus 1 it is on the 2ix. 1 minus of minus 1 it is 2iy. 1 minus 0, 0 it is an Iz divided by square root of 2 square plus 2 square plus 1. 4 plus 4 plus 1, 8 plus 1, 9 whole power of 3 by 2. And the fourth one, 1 minus 1 comma 1 comma 1 of 1 comma minus 1 comma 0. 1 minus 1 0, 1 minus of minus 1 it is under 2 iy, and 1 minus 0 is again plus iz, divided by 4 plus 1 means 5 whole power of 3 by 2. Right. And if we add it and again take that is an LCM and again simplify this expression, therefore you may get the electric field intensity answer maybe this is the value, minus 6.82 Ix plus 6.82 Iy plus 32.8 Iz. Right? If you start to simplify using your calculators, this may be the answer you need to get. And this is the procedure on how to calculate. Like this, any number of the charges may be given. Then we can use it as a superposition. The electric field intensity due to that n number of the point charges is the summation of the electric field intensity of all individual point charges. Right? Okay. And we'll go to that. The next problem. 3 point charges. Q1 equal to 1 millicoulomb, Q2 equal to 2 millicoulombs, Q3 equal to minus 3 millicoulombs are respectively located at 0, 0, 4, minus 2, 6, 1, 3, minus 4, minus 8. Calculate the force on Q1. Right? Now given it is Q1 which is equal to 1 millicoulombs and which is located at 0, 0, 4. Whereas the Q2 which is 2 millicoulombs and which is located at minus 2, 6, 1 and Q3 of minus 3 millicoulombs and which is located at 3, minus 4, minus 8. And what he is asking us to calculate, find the force on Q1. So find the force on Q1 is nothing but, so what is the force on Q1 due to Q2 plus due to Q3, that is F is equal to, find force on Q1 equal to, what is the force on Q1 due to the Q2 plus the force on Q1 due to Q3. So this is what is the force on Q1 due to Q1 and due to Q2. So what is the force on Q1 due to the Q2? Q1 Q2 divided by, that is 10 power minus 3 into 2 into 10 power minus 3 divided by 4 pi epsilon naught into, where we have to calculate on Q1. So which is located at 0, 0, 4 due to the Q2. Q2 is located at minus 2, 6, 1 divided by magnitude of 0, 0, 4 minus 2, 6, 1 whole cube plus again the force on Q1, that is 10 power minus 3 into due to Q3 minus 3 into 10 power of minus 3 divided by 4 pi epsilon naught into, where we have to calculate at 0, 0, 4 minus due to which 3, minus 4, minus 8 divided by magnitude of 0, 0, 4 minus 3, minus 4, minus 8 whole cube. And start to simplify this expression, that's all. That will be gives as an, what is the total force on Q1 due to Q2 and due to Q3. So where we may get the answer by simplifying this, substituting the epsilon naught as an 1 divided by 36 pi into 10 power minus 9 and again simplifying this expression, you may get that the answer is 142 Ix minus 364 Iy plus 10 Iz newtons. Whereas the electric field intensity, the units are volt per meter or Newton per Coulomb. Whereas for the force, the units is the newtons. So the units are must to represent the answers. Okay. So calculate yourself by using the calculators and try to see that and whether you are getting it is in the same answer or not. Okay. Can we move on to the next problem? So the next problem, the point charges Q1 and Q2 are respectively located at 4, 0, 3, minus 3 and 2, 0, 1. If Q2 equal to 4 nanocoulombs, Find the Q1 such that the electric field intensity at 5, 0, 6 has no Z component. The force on a test charge, it is nothing but again the electric field intensity at 5, 0, 6 has no X component. So it is a different kind of thing. Now we'll look into this. So once if you go through the problems, understand it, and again write that what it is given. So what are the things are given here? The point charges, the Q1 and Q2, 2 point charges are given. Let us write it is on the Q1 and Q2. They are respectively located at, so Q1 is located at 4, 0, minus 3 and the Q2 is located at 2, 0, 1. If Q2 equal to 4 nanocoulombs, Q2 value is given 4 nanocoulombs, and find the Q1 such that the electric field intensity at some other point has no Z components. Q1 is not given and is asking us to calculate the electric field intensity at a point 5, 0, 6. In that, where the A bit is, it has no Z component. The force on a test charge at 5, 0, 6 means at the same point. That is again the electric field intensity. Force on a test charge means electric field intensity only, has no X component. So first we will find out what is the electric field intensity at 5, 0, 6 due to Q1 and as well as the due to Q2. So the electric field intensity at any point 5, 0, 6 due to Q1 is given by, it is Q1 divided by 4 pi epsilon naught into, where we have to calculate, that is important, 5, 0, 6, due to which we have to calculate the Q1 which located at 4, 0, minus 3 divided by magnitude of 5, 0, 6 minus 4, 0, minus 3 whole cube. This is the electric field intensity at 5, 0, 6 due to the Q1 plus what is the electric field intensity at this point due to the Q2. So that the Q2 divided by 4 pi epsilon naught into, where we have to calculate at 5, 0, 6, due to which it is 2, 0, 1, the charge located at 2, 0, 1 divided by magnitude of 5, 0, 6 minus 2, 0, 1 whole cube. And let us start to simplify this expression. E equal to Q1 divided by 4 pi epsilon naught into, what is this expression? 5 minus 4 Ix, 0 minus 0, 0, 6 minus of minus 3 plus 9 Iz divided by square root of 1 square plus 9 square. 9 square 81 plus 1 82. 82 whole power of 3 by 2 plus Q2 divided by 4 pi epsilon naught into 5, 0, 6 minus 2, 0, 1. 5 minus 2, 3ix, 0, 0, 0, 6 minus 1 plus 5iz divided by square root of 3 square plus 5 square. 3 square is nothing but the 9. 9 plus 5 square, 25. 25 plus 9. So that is an 34 whole power of 3 by 2. And I will write in this expression what are the X components and as well as the Y components. Now if you go through this, E equal to 1 divided by 4 pi epsilon naught is the common in both the cases. And let us will see that what is in the first case, what is an X component. Here it is an Ix divided by 82 whole power of 3 by 2. That is Q1 divided by 82 whole power of 3 by 2 into Ix plus, in the second case, here it is an Ix component is Q2 into 3Q2. 3Q2 divided by 4 pi epsilon naught into 34 whole power of 3 by 2. 3Q2 divided by 34 whole power of 3 by 2 into Ix. This is an Ix component in both the cases is considered. So here 3 by 34 whole power 3 by 2 Q2. Here it is an 1 divided by 82 whole power of 3 by 2. Next I will write it is an Iz terms. Iy terms, there is no Iy terms. Iz terms I will write. Here it is an the 9Q1. Here it is an 5Q2. 9Q1 divided by 82 whole power of 3 by 2 plus 5Q2 divided by 34 whole power of 3 by 2 into Iz. Correct. So this is what the electric field intensity. If I segregate it is an what is the Ix components and Iz components. Let us will go ahead with the first bit. What is asking? The electric field intensity has no Z component. No Z component is nothing but the Iz component equal to 0. That means 9Q1 divided by 82 whole power of 3 by 2 plus 5Q2 divided by 34 whole power of 3 by 2 into 1 divided by 4 pi epsilon naught equal to 0. If I send the 1 by 4 pi epsilon naught on the other side equal to 0. So this is what is given. Therefore, he is asking us to calculate the Q1. So just it is and solve this problem where it is 9Q1 divided by 82 whole power of 3 by 2 equal to minus 5 into Q2 is given. How much the Q2 is given? Q2 is equal to 4 nanocoulombs. 4 into 10 power minus 9 divided by 34 whole power of 3 by 2. If you solve this the problem and you will get it is and what is the Q1. That Q1 maybe it is and you may get minus 8.323 into 10 power minus 9 coulombs. This is what the answer for the first bit. In similar way, is asking that the second bit is the force on a test charge at 5, 0, 6 has no X component. Means the X component is 0. That is electric field intensity at 5, 0, 6 has no X component. Means I will do that Q1 divided by 82 whole power of 3 by 2 plus 3Q2 divided by 34 whole power of 3 by 2 into 1 divided by 4 pi epsilon not equal to 0. And again I will solve this this equation so that what is the Q1 value where Q2 is given is an 4 nanocoulombs I will substitute. Then you may get it is and the answer is minus 44.945 into 10 power minus 9 coulombs. Right? So understood that, and he is asking us to calculate the electric field intensity at a point 5, 0, 6. We calculated. Then he is asking that the total electric field intensity at that particular point, it may not have that any Z component. Then calculate what is a Q1. If it has no X component, calculate what is an Q1. So these are the two problems. This is an A bit answer and it is an the B bit answer. Okay. Right? Understood? Then we'll move on to the next problem. 4 10 nanocoulomb positive charges are located in the Z is equal to 0 plane at the corners of a square 8 centimeters on a side. A fifth nanocoulomb positive charge is located at a point 8 centimeters distance from each of the other charges. Calculate the magnitude of the total force on the fifth charge. Let us go through this problem. There are the 4 10 nanocoulomb positive charges are located in the Z is equal to 0 plane at the corners of a square 8 centimeters of each side. 8 centimeters of each side. A fifth 10 nanocoulomb positive charge is located at a point 8 centimeters distance from each of the other charges. Calculate the magnitude of the total force on this, the fifth charge. So, given it is a 10 nanocoulomb charge, 10 nanocoulombs charge of identical charges of 4 charges which are located onto the Z is equal to 0 plane. Means in all the cases the point it is an Z equal to 0. At the corners of a square 8 centimeters on each side. Let us I will take it is in a rectangular coordinate system. This is x-axis, y-axis, z-axis. So the xy plane, I will take right. It is kept at 8 centimeters on each distance. This is an 8 centimeters, 8 centimeters, 8 centimeters like this. Then what is the each of the charge distances? And a fifth charge of 10 nanocoulombs are located at a point 8 centimeters distance from each of the charges. Okay. A fifth 10 nanocoulomb point charge is located at a point 8 centimeters distance from each of the charges. Now these are 8 centimeters apart, all these are, and which are kept at the corners of a square. Then what is this point here? This is on positive side, x and y on positive side. Suppose it is and the distance is equal to 8, each side is 8 centimeters. Then if this point maybe it is an 4 comma 4 comma 0 if I assume, and if this point is it is on to the negative side of this, therefore it is 4 comma minus 4 comma 0. So if I calculate what is the distance here, square root of x1 minus x2 minus x1 square plus y2 minus y1, therefore 4 minus 4 0, 4 plus 4 it is an 8 square and this is an 8. Okay, it is suitable now. Then this point will be onto the negative side, it is minus 4 comma it is an 4 comma 0, and this point will be becomes where it is an y is equal to minus 4, it will becomes minus 4 comma minus 4 comma 0. So therefore this distance is also 8 and this also distance 8 and this, yes, perfectly. So now see that all this is a square where the point charge of 10 nanocoulombs is located onto the z is equal to 0 plane at the corners of a square, in each of having the side equal to 8 centimeters. If you see that all these the points, I am assuming it is an at minus 4, minus 4, 0, minus 4, 4 comma 0, 4 comma minus 4 comma 0, 4 comma 4 comma 0. If you look at it in all these points, it is at z is equal to 0 plane. Z coordinate is 0 in all the points where the x and y coordinates are changing, such that if you take it is on the distance from any of these two points, the distance must be 8 centimeters. See that here it is minus 4 minus 4 0. It is 4 minus 4 0. Minus 4 minus 4 it is an minus 8 square. Minus 4 minus of minus 4 means 0 and 0. 8 minus 8 square under root of it is an 8 centimeters. At anywhere the distance if you calculate you may get it is an 8 centimeters only. And again he is saying that a fifth 10 nanocoulomb point charge is located at a point 8 centimeters distance from each of the other charges. Each of the other charges. Therefore, what is the distance and at where it is located? So to calculate that, suppose I am taking it is and it is located at 4 comma 4 comma 0 here, minus, and it is located at some other point of assume that at 0 comma 0 comma at z onto the z axis at a distance of what at where it is located we will calculate, and is equal to it will be gives as an 8 centimeters, means the magnitude of this has to be become this an 8 centimeters. Therefore if I calculate this, then we may get it is and the point is it is an 4 square plus z square, means it is an under root of 4 minus 0 4 square plus 4 minus 0 4 square plus z 0 minus z square, means z square equal to 8 centimeters, means it is under root of 16 plus z square is equal to 8, or it is square root of 32 plus z square is equal to 8, or it is 32 plus z square is equal to, I will get it is an 64, or z square is equal to, I will get 64 minus 32, 32 I will get, or z is equal to square root of 32, or z is equal to, I can write 8 into 4, or 16 into 2 I can write, 16 is nothing but 4 into root 2. Yes, so The point is at a distance of 4 into root 2 centimeters from the z-axis. That is, the fifth charge is located at a distance of 4 into root 2 centimeters onto the z-axis. Therefore, the fifth charge is located at 0, 0, 4 into root 2 centimeters. Then we'll start to calculate what is the magnitude of the force onto this the fifth charge. Therefore, the force is given by F is equal to, where it is located, the fifth charge is at 0, 0, 4 root 2. And where all the charges are located at, so the first charge maybe it is located at -4, -4, 0. The other one it is -4, 4, 0, 4, -4, 0, 4, 4, 0. So due to these, all these are 4 charges, and what is the force onto that? A 10 nanocoulomb charge which is located at 0, 0, 4 root 2. Therefore, the force is equal to, F is equal to, I'll find out, it is a force on 10 nanocoulomb point charge. Due to that, again the 10 nanocoulombs of charges of equal, and they are located at different points of, now here the charge Q1 may be located at where we have to calculate finally 0, 0, 4 root 2. 0, 0, 4 root 2 minus, due to which first charge I will assume that 4, 4, 0 divided by magnitude of 0, 0, 4 root 2 minus 4, 4, 0 whole cube plus. And this is also 10 nanocoulomb charge, fifth one, and all are 4 positive charges are of identical. Therefore, again this is the common for each force. Therefore, the next one it is 0, 0, 4 root 2 minus, it may be -4, 4, 0 divided by magnitude of 0, 0, 4 root 2 minus -4, 4, 0 whole cube plus the other two are again at 0, 0, 4 root 2 minus the other one it is 4, -4, 0 divided by the magnitude of 0, 0, 4 root 2 minus 4, -4, 0 whole cube plus again it is an fourth charge 0, 0, 4 root 2 minus -4, -4, 0 divided by magnitude of 0, 0, 4 root 2 minus -4, -4, 0 whole cube. Just we know that and where the charges are located and what is the distance of the fifth charge and where it is located, we calculated. The rest of the things is only that to simplify. Simplifying all these expression, you may get the answer is 3.98 into 10 power of -4 newtons. That's all. Right? Here it is, and once again I will summarize that. Here it is, and the difficulty part is given it is an 10 nanocoulombs of the point charges which are located in z is equal to 0 plane at the corners of a square, and square is of having the side length of 8 centimeters. Therefore, there the invention is we have to know that what are those points where the 4 point charges are located of this square of corners. So, as it is an z is equal to 0 plane, the first condition is in all the points z coordinate is 0. Remaining is we need to get it is an 8 centimeters, and again it is symmetrically with respect to the coordinate system if it is located. Therefore, I am assuming it is an, so the total distance between the 2 points to get it is an 8 centimeters. Half of that I am assuming. Therefore, each distances of the coordinates, if I assume that one of the coordinate in x and y axis, we may get it is a negative sign, so that it may be of having it is an total of 8. So, like that we have been chosen these are points. So, this is an first thing. And again, the last point is the fifth is at equal distances from all the points. Therefore, equal distances from all the points is nothing but I am taking it is an xy coordinates of anything, either it may be 4, 4, 0 or 4, -4, 0 to get equal distance from all the points, that the fifth point coordinates may have that x and y values are 0 and it is of having only z value. Therefore, taking it is on the z and finding it is an its distance. That distance is given it is an 8 centimeters. Therefore, we calculated what is the z coordinate. Z coordinate is 4 root 2. Therefore, the fifth point may be at a distance of, it is located at 0, 0, 4 root 2. So that if you find out from that point to that any point, the distance will be the same. Then by knowing all these things, then we started to calculate what is the electric field, what is the force at this point due to these the 4 point charges. Then we calculated and that value may be is equal to 3.98 into 10 power minus 4 newtons. Let us will see that one more problem. There are 8 identical point charges of q coulombs. Each is located at the corners of a cube of side length with one charge is at the origin and side length of a meters with one charge of is at the origin and with the 3 nearest charges are at a, 0, 0, 0, 0, a, 0 and 0, 0, a. Find the expression of a total vector force on the charge at a, assuming it is in a free space. So previous problem is given it is in a square corner. Now a little bit difficult of it is equal point charge of q coulombs of it is 8 identical point charges located at the corners of a cube of having the side length of a meters. Let us see here. Now we will consider a coordinate system. This is x-axis, y-axis and this is the z-axis. It is at the origin. It is at the origin and, and assume that this is an a meters onto the x-axis. Therefore, this point will be becomes as an a, 0, 0. And let us take this is on another point onto that the y-axis. Therefore, this point will be becomes 0, a, 0. Let us it is an another point onto the z-axis. Therefore, this point is at 0, 0, a. So, these are the nearest locations and this is an the origin where it is 0, 0, 0. And now, if I combine these two together, if I draw that the perpendiculars from x and y axis and this point of intersection is onto that the z is equal to 0 plane where it is of having x coordinate is in a meters and y axis is also a meters and z is equal to 0. Okay. And now from here I will move it is an a meters onto the z axis. Onto the z axis and this point will be becomes as an a, 0, a. Okay. And from here I will move it is an onto the z axis of a meters. Then this point will be becomes a, a. And from here I will move onto the z axis. Then this point will be becomes 0, a. Then I will combine all these points together. See here. So these are all the points where it is. One is located at, this is 1 point, second point, 1, 2, 3, 4, 5, 6, 7 and 8. 8 is and also with one of the charge is located at the origin. So these are the cube and each of having that the charge of q coulombs which is located at the corners of the cube and is asking us to calculate what is the force, total vector force onto the charge at a, a. Therefore, force is equal to, I will write it is an q divided by 4 pi epsilon naught into due to that the first charge, assume that where we have to calculate at a, a minus, due to that the first charge 0 comma 0 comma a divided by the magnitude of a comma a comma a minus 0 comma 0 comma a whole cube plus like that. The second charge, it is at a comma a minus, second is at a comma 0 comma a divided by the magnitude of a comma a minus 0 comma 0 comma a whole cube plus third charge again a comma a minus third charge is at a comma 0 divided by the magnitude of a comma a minus a comma 0 whole cube plus like that. We'll calculate for all the things. This is for due to that the first charge, second charge, third charge, and again the fourth charge, and again fifth charge, sixth charge, and as well as seventh charges. All will calculate and we'll start to simplify it. Then you may get that the answer is the electric field intensity is given by Q divided by 4 pi epsilon naught into 1.9 into Ix plus Iy plus Iz. So therefore, if we start to calculate here, A minus 0, A into Ix, A minus 0, A into Iy, and A minus A 0. So here you will get Aix plus Aiy, first one, right? Like that, and if you do that all the things and again start to simplify it, and you may get the answer. The electric field intensity is Q divided by 4 pi epsilon naught into 1.9 Ix plus Iy plus Iz. So the thing is only to know that and where it is located and what are its coordinates of that those the 8-point charges. So given it is in a cube where it is of having each side length of a meters. If you observe here, if you see that each side length is the a meters only here. Wherever you calculate that, the distance between the 2-point charges, if you start to calculate, all you will get it is in the a meters only. I hope you understood that these are the problems. So this is how we can use or apply that the Coulomb's law to calculate the problems, that is the force and the electric field intensities due to the different charges. So to summarize that, in these sessions, we solved the problems to calculate the force or the electric field intensity. If it is a 2-point charges are there, 3-point charges are there, how to calculate the force or the electric field intensity, or if the charges may not be given at the electric field intensity at any point, if it has no z component or no x component, and how to calculate the charges, or if it is 4 charges are given and where the locations are not given, but it had been given the logic of it is symmetrically distributed and it is located at the corners of a square, and each side length of a square corner is of having 8 centimeters, and calculate at a point where it is at equal distance from all the points of 8 centimeters, that we solved a problem where that all the location of the points coordinates we calculated, and where that the fifth point is located also that the location we calculated. From that we calculated the electric field intensity, and again at the last problem we had been given 8-point charges which are located at the corners of a cube of each side length is an a meters. Then also we calculated symmetrically by considering it is in a coordinate system, and where that coordinate points of all the 8 points of a cube, what are those coordinates we calculated, and again at 8th coordinate or at point a comma a, what is the force or the electric field intensity due to that remaining all the 7-point charges, each of having a charge of q coulombs located at different points we calculated. So this is the applications of Coulomb's law. By applying the Coulomb's law, how to calculate the force or the electric field intensity at any arbitrary point due to n number of or discrete point charges. Thank you so much, and again we'll meet in the next session and we'll do that some more problems on continuous charge distributions. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.